In this video we're going to think about area, and I'd like to take you all the way back to the very beginning, when you very first started learning about area, almost certainly at primary school. I will start thinking about area by going back even further and asking you about length. So to start with, I have a black line drawn here on the screen, and my question is, how long is the line? How do you work out how long it is? Well, you might say you measure it. So you might need a ruler, something like that. And it's all very well saying you measure it with a ruler, but you need to decide how long 1 is. Okay, so that's what we call units. So what we do is we decide that, for example, this is a length of 1. Okay, it's a centimetre. Okay, this is a length of 1. And then you could count how many ones, how many centimetres go into this line, and you just count how many of those fit in there, and that's what we call length. Of course, you didn't have to choose the 1, the unit, to be centimetres. You could have chosen inches instead, or there's lots of other units. You could have chosen millimetres, which is this really tiny one here. But basically, length is measuring how many of those, or those, go into that. You just count how many there are. So I might go on and ask, what is area? Have a little think about it. What is area? Did you say something like this? Did you say something like this? It's not what I'm looking for. It's not 100% incorrect, but it's definitely not correct either. These are what I would suggest are common wrong answers. Certainly to the question, what is area? These don't answer that question. Recall that length is how many of these things fit into that. Just count how many there are. So in the same way, suppose I gave you a shape and said, what's its area? How do you work out the area? What I want you to do is to count how many squares fit inside. And you might decide to use squares which are this size, or this size, bigger ones, like square centimetres, square inches, or even square millimetres, tiny ones. So once you've decided what 1 is worth, you then count how many of these fit in there, or how many of these fit in there, or how many of these fit in there. As you can see, it's really important in both cases, if you're measuring a length or an area, it's really important to decide, well, what do you mean by 1? It's all very well saying, oh, you can fit 53 of them in, but 53 what? That's why maths teachers are absolutely obsessed with units. It is really important to decide what a size of 1 is, because an area is how many of these squares of size 1 fit inside. Okay, so that's what area is. Going to move on then to rectangle. Now you know area now is how many squares fit inside. So this rectangle is easy. It's just I can count them: 1, 2, 3, 4, 5, 6, 7. So 8. This is a rectangle with an area of 8. 8 squares fit inside. It's probably 8 square centimeters. This is a tall, thin one rather than a long, wide one. And this is a 1, 2, 3, 4, 5, 6. So just by counting the squares, I can see that it has an area of 6. If I gave you this bigger one, like so, how many squares are in there? You could just count them. You'd be kind of mad to count every single one individually. What you'd probably do is say, well, there's 8 in one row, and I can see that there are 6 rows like that. So if there are 8 rows, each with 6 in, that must be 48. 6 times 8 is 48. You could instead have said that one column has 6 squares in it, and there are 8 columns like that, so 6 times 8 is 48. This justifies why the shortcut is multiply the numbers together. Okay, so you would have known that a long time ago, but I'd be willing to bet that you'd forgotten it. I'd be willing to bet that you've forgotten that area could just be counting squares. For a rectangle, however, there is this shortcut that you can multiply how many squares are in the length, how many squares are in the width, and you can quickly count all the squares. But it is just a shortcut for counting the number of squares that fit inside. Length times width is just a shortcut for counting the number of squares that fit inside the shape. With that in mind then, you could easily work out what the areas of these shapes are. You can just multiply the length and the width together, or the base and the height, however you want to describe the dimensions. So 9 times 4 is 36, so this is 36 square centimetres, written as 36 cm with a little 2, 36 centimetres squared. This one down here, just as easy. Don't worry that it's a decimal, but 0.2 times 10. Just move the point along. You get 2 square centimetres. Notice how they're not drawn to scale. Be careful here. There is a trap. Okay, the common mistake would be to just multiply 70 and 12. That would not be correct. Notice how the units are different. Once again, not to scale, dramatically not to scale, because it is slightly less than 1 metre, and this is meant to be 12 metres, so it's not to scale. If I do want to work out the area, I need to make them both the same units. So I could make them both metres, that's already metres. This would be 0.7. So just on my calculator, I'm typing in 0.7 times 12, and that gives me 8.4. So this is 8.4 square meters, or 8.4 meters squared is how you would write that down. Alternatively, you could have made them both centimeters. This is 1,200 centimeters. So 1,200 multiplied by 70 gives us 84,000. 84,000 square centimeters. Notice that that was 8.4 square meters and 84,000 square centimeters. So we don't just multiply square centimeters by 100, do we, to get square meters? If you do want to switch between square centimeters and square meters, that's actually 10,000. 10,000 is the scale factor. So be really, really careful. The whole point of all this introduction is just to arrive at the idea that area is not just base times height or length times width. It is for a rectangle. It's the shortcut way of counting the number of squares that fit inside, but I am just counting the number of squares that fit inside.